Dear students, under steam boilers part 3, you studied fire tube boilers, their working and construction. And under fire tube boilers, mainly you are explained about the working of simple vertical boiler, Cochrane boiler, Lancashire boiler, and locomotive boiler. Now, under part 4, you are going to study water tube boilers. I hope you remember what is the difference between fire tube boilers and water tube boilers. Water tube boilers are basically the steam generators in which water flows through the tubes and flue gases surround those tubes to convert the flowing water into steam, right? So we begin with Babcock-Wilcox boiler. Which is a water tube boiler. The diagram is shown here. It consists of a shell which contains steam and water is connected by tubes with headers. These are two headers. This is downtake header. This one is uptake header. This is cylindrical shell in which water is filled up to the water level indicator up to this point. Above this, this is steam space. Various mountings are visible here. This is safety valve, steam stop valve, water level indicator, feed valve, pressure gauge. You can see here. Through this tube, water flows into these pipes, which are water tubes. Water flows like this. It enters into one tube, passes through the other tube, then passes through the third tube, and in the form of steam, it goes into the cylindrical shell again. Here it is the firebox. You can see here where fuel is burned. There is a moving chain grate here over which fuel will be kept to burn. Flue gases will emerge. Those flue gases will pass over these tubes. Baffle plates are provided between these tubes so that the flue gases may get a direction. These flue gases pass over these tubes in one cycle, then pass over these tubes again in the second cycle, then pass over these tubes in the third cycle, and then they'll leave the system through chimney, right? So baffle plates are provided to show the direction to flue gases so that maximum energy can be transferred to water which is flowing through this and converted to steam as early as possible, right? Now we can go through the text that is provided. It's a water tube boiler shown in the figure. It consists of a shell which contains steam and water and is connected by tubes with headers. Water tubes are inclined to the horizontal. Here degrees are not given. Generally, these are inclined at 15 degrees to the horizontal and connected to these headers. It is uptake header. This one is downtake header. Headers and the tubes are properly connected so that the hot gases can pass through after heating all the tubes. Pass over these tubes after heating all the tubes. A mud box is provided with the downside header to remove the mud that settles down. Mud gets settled down here, and this is the mud collector from where it can be removed through the box. There is a moving chain grate to which coal is fed from the hopper. See, from here, from the hopper, coal is fed over this moving chain grate. Grate can be brought here with the help of chain. It will take the coal, again go into the position, and fuel will be burnt here in the firebox. Fire brick baffle plates cause hot gases to move up and down before leaving the chimney. This I already explained. These are the baffle plates which are made of fire bricks to withstand very high temperature, and gases pass through these, then pass through this, then pass through this like this, right? Dampers are operated by a chain to regulate the draught. Draught means it is a pressure difference between inside and outside, and there are dampers here. I explained this earlier also in case of fire tube boilers. With the help of chain, these dampers can be operated and they are regulated such that you can maintain the required pressure difference inside and outside for the proper flow of these gases. Doors are provided for a man to enter the boiler for repairing and cleaning. As usual, manholes are provided here also, through which manholes may be 1, 2 or more, depending on the size of the boiler, for the repairing and cleaning purpose. Man enters through the hole and repairs or cleans. Water circulates from the drum to the header and to the tubes till it becomes steam. So once it enters into this uptake header and goes to downtake header, then to uptake header, then to downtake header, finally in the form of steam, it leaves this system, goes to the steam space. Right? Here you see these tubes. These are superheater tubes. So after getting converted to steam, it enters into this dry pipe. Through this, it enters into superheater tube, where these flue gases, which are coming to convert water into steam, the same gases pass their energy to superheater also, where the steam gets superheated and reaches steam stop valve, from where it can be taken to the required prime mover, right, for any application. The steam generated and stored above the water level in the container flows in the dry pipe to the superheater before taken to the outlet pipe to the stop valve. This I have just now explained. Boiler is fitted with usual mountings such as safety valve, feed valve, water level indicator, pressure gauge. ये मैंने शुरू में आपको दिखा दिया था. These are various mountings fitted. So this is a clearer diagram. You can see here all these abbreviations. You can see pressure gauge, I have already shown, superheater tubes, safety valve, here main stop valve or steam stop valve, anti-priming pipe through which steam goes to the superheater, upper junction box U, lower junction box, feed valve here. This is the drum, downtake header, uptake header, water tubes, baffle plates, doors for man to enter, grate, fire door. This is mud collector and water level indicator. All these things I discussed in the previous slides. Here also these are shown very clearly. I hope you understood. Now we are going to discuss very high pressure boilers. Generally, water tube boilers are high pressure boilers. The boiler that we discussed just now works at about 40 to 60 bar working pressure. If you want to go beyond that pressure, there are some modern high pressure boilers employed for power generation with steam capacities from 30 tons per hour to 650 tons per hour, and with pressures up to 160 bar and maximum steam temperature of about 540 degrees centigrade, right? What are unique features of these high pressure boilers? Method of water circulation. You will see one by one these high pressure boilers. Type of tubing that is provided and improved method of heating. With the help of this, high steam generation and high pressure are obtained, high temperature is generated. Lamont boiler is one such boiler. It's a high pressure water tube boiler working with the mechanism of forced convection heat transfer as shown here. Here water circulation is maintained by a pump. In most of the high pressure boilers, water circulation is by pump. Feed water is circulated through the water walls and drums continuously, thus preventing the tubes from being overheated. The feed water first passes through the economizer, then to the separation drum. If you see this diagram, the feed water is entering from here and it is entering into these tubes, which are economizer tubes. What will happen in economizer? The gases which are going upwards from the combustion chamber to the chimney will pass through the economizer, and when these gases pass over these tubes, feed water gets heated up and is raised to a significant high temperature. What is the advantage of it? The advantage is that the feed water which is going into the boiler for getting converted to steam attains high temperature without expenditure of fuel, right? So here fuel consumption will be less to convert it into steam in the combustion chamber, right? So feed water passes through the economizer and then goes into this pipe from where it enters into this drum, which is basically a separating drum where water will get converted as a, will get separated and will come to the lower portion, and steam will remain here to enter into superheater, right? So water will fall through this pipe where with the help of this feed water circulation pump, it will reach the distributing header and then into the boiler, from where it is entering into this radiating evaporator. Radiating evaporator means due to the radiation of the furnace and these gases, this water will get evaporated and convert into vapor form. In this vapor form, it will enter into this separating drum in the upper part, get mixed with the steam that was separated here from the water, and this steam will enter into this superheater tubes where these gases coming upwards will give their energy to this vapor, converted into superheated vapor or steam, and that steam will go to the required application from here to steam stop valve, right? And what about these gases? The gases have worked their, given their energy in this radiating evaporator, then in the superheater, then in the economizer, and finally they will leave through this chimney, right? So this is the working of Lamont boiler. So here you can see the circuit diagram where you can separately see the steam circuit, water circuit, and flue gas circuit. See here, feed water enters here, enters into economizer, gets heated up. With the help of the pump, is dragged into this separator drum. Water will get separated, will come here through this pump, and through this evaporating section will get evaporated and in the form of steam again enter into separating drum. In the upper part, get mixed with the previous steam, go into this superheater, and finally to prime mover, right? Now see the steam circuit, steam which is formed here or collected here, goes into superheater, gets superheated, goes to the prime mover. What about flue gases? Flue gases emerging from the combustion chamber pass through the evaporating section, then to the superheater, partially give their energy, and finally to economizer and then to chimney. Right? So this circuit diagram explains what you learned in the previous slide. The next boiler is a Loeffler boiler. In Lamont boiler, the major difficulty that was experienced during its working was deposition of salt and sediments on the inner surface of water tubes. What will happen due to that deposition? That will reduce the heat transfer and ultimately the steam generation capacity, right? So there should not be any deposition inside the tubes, but that was a major difficulty in case of Lamont boiler. It has another disadvantage, that deposition, that increases the danger of overheating of the tubes, that is due to salt deposition, and it has high thermal resistance. That difficulty was solved by scientist Loeffler by introducing a boiler on his name, Loeffler boiler. In this, mainly flow of water into the boiler tubes is prevented, right? This boiler also makes use of forced circulation, and its novel principle is the evaporating of the feed water by means of superheated steam from the superheater. The hot gases from the furnace being primarily used for superheating purposes. So through this principle, they have avoided or prevented the flow of water into the boiler tubes, right? So now see this text and then diagram. Loeffler boiler is a water tube boiler working with forced convection heat transfer mechanism to evaporate the feed water. Hot gases from the furnace are also used for superheating, as shown here. Feed water from economizer tubes is forced to mix with a part of superheated steam in the evaporating drum. Steam produced is then drawn from evaporating drum by a steam circulating pump and forced through the tubes in the combustion chamber before entering the superheater. About 1/3 of the superheated steam passes to the turbine and remaining 2/3 is used to evaporate the feed water in the evaporating drum. Flue gases from the combustion chamber move to superheater convection tubes and to economizer before moving to the atmosphere through chimney. Now see here, there is a evaporating drum here, right? This is the entry of feed water, which passes through the economizer as usual. You have seen in the last diagram also, last boiler also, that is Lamont boiler. And from here, this hot water comes into this evaporating drum, where it is not passing through any tubes. Here, steam, superheated steam, which is in the gas form at a very high temperature, is passed through this. That converts this steam, this liquid, a hot liquid, into vapor or steam. And that steam through this steam circulation pump is entering into this radiating superheater, where from the furnace gases are passing over these tubes. After heating, those gases will move over this convection superheater, and through this radiation superheater, gases will pass through this, and due to the radiations, this steam gets superheated. Again, in convection superheater, its temperature is raised, from where it is passing to the steam turbine. But before passing to the steam turbine, it is divided into two parts. 2/3 of it goes into the evaporating drum, to convert this feed water into steam, and only 1/3 of it goes to the steam turbine or steam engine or any other application wherever it is needed, right? So in this way, flow of water into the tubes is avoided and that deposition is avoided. In this way, Loeffler boiler is much better over Lamont boiler, although a bit complicated it is, because initially in this evaporating drum, through the steam itself, entire water is to be converted to steam. You can see through this circuit diagram also, this is the feed water going into the economizer, entering into the evaporating drum through circulating pump, radiating superheater, convection superheater, and 1/3 to prime mover, 2/3 to evaporating drum, right? So this is what I explained in the previous slide also. I hope you have understood. The next boiler is Benson boiler. Now the difficulties observed in the Lamont boiler have been removed in Benson boiler. In Lamont boiler, the difficulty of the, in Loeffler boiler, the difficulty of Lamont boiler was removed, and in Benson boiler, the difficulty observed in Loeffler boiler and also Lamont boiler have been tried to avoid. Lamont boilers, another difficulty was formation and attachment of bubbles on the inner surface of heating tubes. The attached bubbles to the tube surfaces reduce the heat flow and steam generation. Along with deposition, these also put up difficulty in steam generation, right? Due to the high thermal resistance. Now, in this boiler, how working is taking place, you can see Benson boiler is a high pressure drumless once through water tube boiler. It is a drumless boiler with forced convection heat transfer mechanism. Everything is self-explanatory. I'll try to explain. Till feed water enters at one end of the tube and is charged as superheated steam at the other end. Feed water pump increases the water pressure to supercritical pressure, and the water directly transforms this into steam without boiling. If you remember the steam properties taught in first year, at critical point, there is no requirement of latent heat of vaporization, and directly the entire water gets converted into steam without boiling. So if that pressure is attained, then without any input of energy, the entire water can be converted to steam. That principle has been used in Benson boiler. Feed water passes through the economizer to the water-cooled walls of the furnace, where it receives heat by radiation and temperature rises to almost critical temperature. See here, this is the air fan through which air is taken and passed through this air preheater, which will be used for combustion purposes at two places. Primary air, the air sent here is the primary air in the combustion chamber. Secondary air is here, which get mixed with the flue gases. This is radiant water heater, superheater, then economizer. So feed water pump that is used compresses the water to almost critical pressure. At critical pressure, when it enters through the economizer, it is in the almost vapor form, and that vapor directly enters into this radiant water heater or vapor heater, where radiations provide heat to this to bring it to superheated state. That superheated vapor enters into this convection evaporator, where complete conversion to vapor takes place, from where it enters into the superheater, where its temperature is raised to almost critical temperature, and superheated steam at critical temperature comes out of this, right? So here, initial action is to raise the water pressure to critical pressure, right? So thermal efficiency of the Bensel boiler reaches up to 90%, and average operating pressure and capacity are 250 bar and 135 tons per hour. This boiler can be started within 15 minutes to produce the required steam flow rate. So this is again circuit diagram of Benson boiler. Water from the feed pump at critical pressure enters into economizer. Then this radiant parallel tube section, due to radiations, converts into complete vapor. Then this transit section, where, or convection superheater, you can say, from convection superheater to the, radiant superheater or transit section, then to convection superheater, and finally to the prime mover, right? To try to connect it with the previous diagram, you'll be able to understand. This is another boiler called Velox boiler. You are aware that when gas velocity exceeds the sound velocity, heat is transferred from the gas at much higher rate than rates achieved by subsonic flow, right? The advantage of this theory is taken to effect. The large heat transfer from a smaller surface area in this particular type of boiler called Velox boiler, right? This boiler basically makes use of pressurized combustion. Here, gas turbine drives the axial flow compressor. Here, see, this is a axial flow compressor. This is a gas turbine which is run by the flue gases which are going into the atmosphere. They will be losing their energy in the atmosphere unnecessarily. That energy is used to run this gas turbine. That gas turbine runs this axial compressor, right? The combustion gases, after heating the water and steam flow through the gas turbine, go to the atmosphere after passing through this economizer, right? Feed water after passing through the economizer is pumped by a water circulating pump. Here, this is water circulating pump. This is feed water, enters into economizer, goes to water circulating pump, where this is evaporating section. Through evaporating section, these gases pass into this, where steam separating section separates steam, takes it to convection superheater, and then to prime mover. Remaining water again comes to the radiant or evaporating section, right? Now, what is the main purpose of this axial compressor? This is run by the waste gases through this turbine, and this axial compressor takes the air and at a high pressure sends into the evaporating section, just to help in conversion of vapor into steam. The size of Velox boiler is limited to 100 tons per hour. Sometimes the power that is developed by the gas turbine is not sufficient to run the compressor, and some power has to be given from external source. That is an additional disadvantage. At what are advantages? Advantages that boiler is very compact, has a greater flexibility, and very high combustion rate is possible because of this compressed air, and it can be quickly started, right? Since this pressurized air is used, low excess air is required, right? And problem of draught, that is maintaining the difference of pressure, is simplified with the help of this. With this, we finish water tube boilers. I hope you have understood well various types of fire tube and water tube boilers. You can come up with problems if any. Okay. Best wishes. Good luck.